Okay, I think we're finally there. 3.4. Can you guys see that?
Mm-hmm.
Okay.
Yeah.
Good. All right. So 3.4 is on linear inequalities. So we're going to be graphing inequalities. So there's lots of answers. And so to describe all the answers, we shade the region that gives us the answers. So we graph a boundary line, which is the line that is associated with the problem. So here we'd start at a y-intercept of -2, slope of 3/4. So rise 3, run 4. Rise 3, run 4. We can even go down 3 and left 4 would have the same steepness. So get that off there. 1, 2, 3, 1, 2, 3, 4. Okay. Now because it's greater than or equal to, it is going to have a solid line because it's including those. Equal to meaning including. So I make a solid line through those. So that's the boundary line. And then to decide what side to shade, we test a point to see if it's in the solution region or not. The easiest point to test is 0, 0 if it's not on the line itself. So I'm going to test this point 0, 0 here. So I plug in 0 in for the x and the y. 0 times anything is 0. So I have 0 greater than or equal to 0 minus 2. Is 0 greater than a negative? It is, so this is true. So it is a solution. And so because it's a solution, I get to shade it. And every other point on that side would also be a solution. You also will have problems where it might not be in slope-intercept form. Sorry about the baby.
Okay.
Like this one is in standard form. So like we practiced earlier, we want to get y by itself.
Okay, just a second. I put you down for just a second. You're okay. You're okay.
And then divide by 3. Because we're dividing by a positive, our inequality stays as it is. And I'm going to divide both of those by 3. And so that is what I'm going to be graphing as my boundary line. You could also have found the intercepts, like plugging in 0, and then the y would be 2, or plugging in 0 for the y, and the x would be 3 to make the statement true. And you'll see 1, 2, 3, that if I start at 2 as a y-intercept, I go down to over 3, that I do land there. So you could also have plotted this using the intercept method. Again, it's greater than or equal to. The equal to means it's going to be a solid line. Now, for testing a point, these are equivalent expressions, equivalent situations, and so I can either plug in my 0, 0 into the original or into this equivalent one. I recommend this one in case you make a mistake along the way. So if we plug in 0, 0, we would have 2 times 0 plus 3 times 0. That gives you 0. That gives you 0. 0 plus 0 is 0. Is 0 greater than or equal to 6? Well, this time the answer is no. 0 is not greater than or equal to 6. You're going to have to move her because I can't do this with you.
Yeah.
So this 0, 0 test point was not a solution. So I cannot shade that side because that's not a solution. So I'm going to shade this side. So this next one only has an x, and so it's one of those special cases. It's that Vux case, if you remember me from a prior lesson doing OI Vux. The vertical line, undefined slope, x equals some number, no y's. X is less than -3. You can also think about the number line. This is your x-axis, go to -3. We want everything less than that. So we don't want it itself, so I'm going to use a dashed line this time. And everything where the x's are less than 3, all these x's are less than 3. Or you could have tested a point by plugging in 0, 0 which really you can only plug in the 0 because you only have an x. Is 0 less than 6?
Yes.
Wait a second. Hold on. I have made a mistake. I didn't even notice it. Sorry. Is 0 less than 6? Would it actually be a yes? I should have shaded this side. And my mistake was I did not switch the inequality sign. I was thinking it and didn't do it. Because I divided by a negative, I need to switch that inequality. So I actually wanted it to be greater. And I don't see my whiteout, so. The blue part's correct. So this kind of covers the main 3 examples where it's in slope-intercept form and you have a yes. This covers a non-slope-intercept form where you have to convert. It also covers the no situation. And this one covers the dashed line situation and also a vertical line. And it also talks about switching the inequality. Hopefully you remember, unlike me, to switch it. So the only other one that is kind of important to maybe review briefly is a situation like this where the y-intercept is 0. Rise 2, run 1. And this one will also have a dashed line because it's only greater than, not equal to. And this time if I tested 0, 0, let me bring it up just a little bit. If I tested 0, 0, I wouldn't get any information about what side to shade. So I test any other point I want. Maybe I'll test 5, 0. So if I have 5, 0, my y is 0, my x is 5, is 0 greater than 10? No, 0 is not greater than 10. So this is not a solution. So I would shade the other side. Otherwise, these other 2 are just practice with rewriting and practicing the yes and the no. And this one is practicing, we're going to end up dividing by negative, so switching the inequality symbol, and just more practice with the dashed line. Would you like me to do 4 or 6?
I'm okay.
I'm fine on it.
Okay. And here are some directions, if that helps. I think I may have put some directions similar to this on Canvas as well, but if you want to take a screenshot or refer to it later, I'll have it here. Basically, get it into y equals mx plus b. If you multiply or divide by a negative, switch your inequality symbol. Shade the side that makes statements true. Solid line for the equals ones and a dash line if it's not equal to. And here's that car problem that we actually worked on, Julie, at the beginning of the session. But I think we already talked about it, so I'm going to move on.
Okay.